We have already seen two methods of heat transfer: conduction, convection. Metals are very good conductors. Non-metals, liquids and gases, in the same order, their conducting ability of heat reduces. Convection happens only in fluids, that means liquids or gases. But if you think of all these methods, all these two methods, there is a need for a medium. And if you look at life on Earth, it has originated from sun. Sun is the source of energy for all forms of energy in Earth. And fortunately or unfortunately, there is no matter between sun and Earth. If you think of sun like a stove burning and Earth like a kettle, in the case of the stove and the kettle, there is the possibility of the flame coming in contact with the stove and conducting. And within the water there is convection. But if you look at sun and the earth, there is no matter, no atoms, no molecules in between. There is emptiness, vacuum. So still we need some way of transferring energy, heat energy. The third method is a way of transferring energy without using any medium. That's the speciality of it. So when it comes to conduction, it has a speciality that it is superb in metals, because there are two ways, that is vibration, free electrons. Metals have free electrons, so conduction is like the speciality of metals. When it comes to convection, you need molecules which can move around, so fluids become the specialists in convection. When it comes to radiation, its speciality is it can travel through vacuum. It does not need a medium. So that's the first point that you should understand. And it's an energy transfer that is happening without the help of mediums, so that's an electromagnetic wave as well. And you will find thermal radiation in the electromagnetic spectrum under the name infrared radiation. So the visible light region in the electromagnetic spectrum has violet on one end and red on the other end. This is infrared. Thermal radiation is technically called infrared radiation, and it's part of the electromagnetic spectrum. Now, depending on the certain properties of the surface that is there, the amount of this heat absorbed is going to change. Basically, two things are important: color and the texture. So these are the two properties as far as the material or the surface is concerned that will determine how much radiation is going to be absorbed or how quickly it's going to be absorbed. Now, black surfaces and dull, or we call it them matte black surfaces, so this is texture, this is color. So these surfaces are very good absorbers. It's very tempting to think that a very good absorber of radiation would be a very poor emitter of radiation, but that's not the case. Actually, the vice versa. A very good absorber is a very good emitter as well. So please get that very clear. If something is a very good absorber of heat, it would also be a very good emitter of heat. Okay, so black color, dull or matte textured surfaces are very good absorbers and emitters. At the same time, white and very shiny surfaces are poor absorbers and emitters. The reason is they can reflect, without absorbing it, they can reflect the radiation. So it's kind of, black is the favorite color of radiation. Beside color and texture, there are two other things which can affect the rate and the amount of radiation, that is the surface area of the object and the surface temperature. So that means when you have a hot cup of tea, when it cools faster in the beginning compared to the end. That means, let's say your cup of tea is 35 degrees Celsius. So in the beginning it loses more energy per unit time compared to after 5 minutes when its temperature is say 30 degrees Celsius. So when the surface temperature reduces, the rate at which radiation happens reduces. And obviously when you have a big mug, you're going to emit more radiation. So surface area, temperature, color, texture.